Today we will be solving LeetCode 1027, that is longest arithmetic subsequence. So in this question we are given with an array nums of integers and we have to return the length of longest arithmetic subsequence in nums or given array. And we all know that arithmetic subsequence is nothing but a series of integers where the difference between these integers is constant. Like we can see in example 1, there is 3, 6, 9, 12, and we can see that 6 minus 3 is also 3, 9 minus 6 is also 3, and 12 minus 9 is also 3. So as the difference is constant, so we can say that this whole array is an arithmetic subsequence, and therefore we return the length of array as output. So how we can solve this question is something we will see. So we are going to utilize this example number 2, for understanding how we can approach this particular problem. So the first brute force approach that I can think of is, like, first thing is very clear to us that we need a difference, right? We need a difference between two values for checking whether the rest of the integers are in series or not, arithmetic subsequence or not. So for that we always need two integers. So let's consider this is our left value, this is our right value, and we will do right minus left for calculating difference. After getting this difference, how we can check the existence of arithmetic sequences? We can do r plus d, and whatever the value is, we will check the rest of the array. If this value exists in this portion of the array, then we can say that yes, there is a series present. Else what we can do, we can increase our pointers, or we can say we will move forward and check the difference between another two values, that is 9 and 7. Then again we will do the same thing, we will subtract 7 minus 9, and whatever the difference will be, we will again add the right value to it, and then we will check from 2 to 10. So this whole approach will take how much time? As for left and right values, we need two nested loops, so it will take big O of n square, and then after getting the difference and getting the sum of right value and difference, we will check for the existence of the arithmetic sequence, and in worst case it will take big O of n times, so the overall time complexity will be big O of n cube, and we all know that this is most likely to exceed time limit. Therefore we can't proceed with this approach. So how we can optimize that? So now what we will be doing, rather than taking left value and right value, we can take left and right as a range. So now this is our range, and what we have to do is we will check for all the arithmetic sequence in this range, and this is how we will be calculating for all the ranges. Like for firstly 9 and 4 will be our range, then 9 to 7 will be another range, then 9 to 2, and then 9 to 10. In this manner we divided this whole problem into smaller sub problems, right? And we all know that this approach is known as dynamic programming. So we will be solving this whole problem using dynamic programming approach. Now we know that in dynamic programming we also use memoization. So in this problem, where we can use it, we can see it very clearly that the traversal that we are having in this range is going to be repeated in the next stage or next further traversals, right? We can see this portion is going to be repeated, and then this portion is also going to be repeated. So how we can cut off the computational time, we can, or the traversal time, we can save the result of this traversal so that we can utilize it when we are going to traverse this next range, right? And then again we will be storing the result of this traversal so that we can utilize in next traversal. And this is how we will be using the memoization trick too. Now let's see how we are going to store our data and what we are going to store. So firstly, what we have to store, we need to check, and secondly, what will be the data structure that we will be using. right? So first thing that we can see is there are elements in array, and these elements are going to have differences in the sense we will be calculating differences like for 9 and 4, then for 9 and 7, then for 9 and 2, then for 9 and 10. So we can see one element of array is going to have multiple differences, and with all these differences we know that the ranges keep on changing, so the length of arithmetic subsequence will also be changing, right? Different. So how we can store this? We know that 9 minus 7 is also 2 and 4 minus 2 is also 2. So only on the basis of difference we can't store the value, right? So how we are going to store the value so that we can refer it again, and it should always be unique in some sense so that we can check in our next step is, suppose we are at this step, this is our left pointer and this is our right pointer. So how we will be storing it? We will be storing it as right pointer, then the difference and the longest subsequence in that particular range. And this is how we will be storing the values in our data structure. So that when we are going to increase our right pointer, suppose it will go to here and we have stored this value. So when right is here, our left pointer will be at this place. So every time when we are traversing, when we are storing data, it will be in this format, and when we will be checking for the existence of that data in our data structure, what we will be checking? We will be checking left and the difference, because in the next step our range is going to be incremented, right? So we won't be getting the same value, but we know that our left pointer is at that value, can be at that place, right? So we will be checking for left pointer and difference. If these things doesn't make sense right now, not an issue, because we will be going through the whole array once using this approach, and we will try to visualize the whole approach. So at that point of time, things will become clear. So okay, let's start and see how we can solve this example using this approach. So at first my right pointer is going to be here and my left pointer is also going to be at this place. Now one condition that we will always checking is our left pointer should always be less than right pointer, then only we are going to check that particular range. Okay, existence of subsequence, because we know that we need two values to get a difference and then check the existence of arithmetic sequence. So when both the pointers are at same position, we won't be able to do that. So our left pointer should always be less than right pointer. Now I will be increasing our right pointer and it will go to 4. So now what I am going to do, I am going to do right minus left, that is 4 minus 9, difference is minus 5. Now I know that we need to check what? The existence of left value and the difference in our DP. So how we will be storing our DP, as we discussed, to make the value unique, we will be storing right pointer and the difference as a key and the length of the subsequence as the value. So right now as our DP or hash map is empty, so we will be simply inserting this value. How we will be inserting? When we are going to insert, we will keep right value, that is 4, and minus 5 is equivalent to 2, because right now these are two elements, right? Then we will increment our left pointer. It will become equivalent to right pointer, so we'll step out this nested loop and we will increment our right pointer, so it will go to 7. Now what we will do, our left pointer will always start from 0 because we have to cover that range as we discussed previously. So now our right pointer is at 7 and left pointer is at 9. So what we are going to do is 7 minus 9. The difference is minus 2. Now what we will be checking? We will be checking left pointer and the difference, that is 7 and 9 and 2. 9 and 2 is there in our array, in our hash map? No. Then what we will do, we will simply insert right value, difference, and the length of consecutive sequence. Now we will again increment our left pointer. Our left pointer will come here, and now what we will check, 9 minus 4, this is 3. We know that 4 and 3 is not present in our hash map, so we will be inserting the right value, that is 7, and difference, that is 3, and the length. Now we will again increment our left pointer. It will become equivalent to our right, and we will step out of the nested loop, and again we will increment our right pointer. It will go to 2. Now we will again check right minus left, that is 2 minus 9, it will be minus 7. Then we will check the left value, that is 9, and the difference minus 7 is not there in our DP hash map, so we will simply insert right value, that is 2, and difference as a key, and this is the length. Then again we will increment our left pointer. It will come to this place, and we will do 2 minus 4, it will be minus 2. Now we will check 2 and minus 2 is not there in our hash map, so we will insert what, 2 and 4, and minus 2 is not there in our hash map. 4 is that left pointer, that's my bad, and 2 and minus 2 will be inserted with consecutive with the subsequence length. Now again our left pointer is going to be incremented. It will be at 7, so what we will check, 2 minus 7, so this is minus 5. Now again left value, that is 7, and minus 5 is not there in our hash map, so what we will insert, 2 and minus 5 equivalent to 2. Now again we will increment our right pointer, because when we are going to increment our left pointer, it will become equal to right, and then we will step out and increment our right pointer. It will come to 10. Now we will do right minus left, that is 10 minus 9, it will be 1, and we know that 9 and 1 is not a key in our hash map, so what we will do, we will again insert the right and the difference and the length. Then again increment left pointer, this is 10 minus 4, this is 6. We know that 4 and 6 is not there in our hash map, so what we will do, 10 and 6 equivalent to 2. Then we will go to 10 minus 7, that is 3. We know that 7 and 3 is there in our hash map, so what we will do, we will increment it by 1, okay, because this was already existing. So in this subsequence, the length is going to be increased by 1. Now we will again increment our left pointer, so it will go to 10 minus 2, this is 8. We know that 2 and 8 is not there, so we will insert it, that is 10 and 8 equivalent to 2, and now we are done with our whole traversal. So we can see now our hash map is having all the subsequences and all the lengths are also there. So now what we will do, we will traverse this hash map and we will return the maximum length, that is this one, 3. So our answer will be 3. So how much time this whole approach took for returning the answer is big O of n square, because for left and right ranges we are having nested loop, so the time complexity will be big O of n square, and space complexity will also be equivalent to big O of n square, as the size of the array will be equivalent to this one, big O of n square. So now let's try to code this whole approach. You will be surprised to see that this approach took this much time for explanation, but the code is going to take only 5 lines. So firstly, let's initialize our hash map. Then for right pointer, you must be thinking why I'm taking right and left from 0, but the thing is, this will take care of all the edge cases so that we don't have to define conditions for different edge cases separately. This loop will take care of it. So these two are going to be our loops with which we will be getting our range. Now in that range, firstly what we will do is we are inserting right and the values difference, right? So nums right minus nums left. This will be the difference. And we will check if this already exists. What we were checking? We were checking if left and this whole thing again, that is nums right and nums left, is existing in our hash map, then take the value, and if it's not existing then return 1, because we will add 1 and it will become 2 if the value is not there, else it will become 3 or the value will be incremented by 1. So this whole condition will take care of our lookup and incrementing part. If the value is there, then it is going to return the value, else we will be getting 1 and we will increment it by 1, so we will get 2, because at the end the length 2 is always going to be there, because we will have two values for calculating the difference, right? And at the end what we have to do, we have to return the max of dp dot values, and we are done. This was the whole code. Now let's see if I had done something wrong. Now it works fine, I guess. Yeah, the whole solution is submitted and you can see it is quite efficient. So this was the whole problem, although my explanation might be a simplified version of this whole problem, but this problem was not a medium question. This problem was a quite hard problem, but now we know how to solve it. So hope you find this video useful, and if this video helped you to understand this whole problem, then you can like this video, subscribe my channel, and soon I will be coming with some more questions. And if you have few questions that you want me to solve, then you can share them in comment section. I will definitely try to solve all those questions. And this was it for this video, and I will see you soon with another question. Thanks for watching.